10th Physical Science, Electric Current. Now we are going to learn about the Ohm's law and electric shock. Here is the activity. The materials taken here: iron spoke, wire and battery. So here, connect the circuit, solder the conducting wires to the ends of the iron spoke and close the key. Note the readings of ampere current measured in amperes, and voltmeter. Voltmeter means potential difference is measured in voltmeter, and tabulate them. So here connect the circuit. So all these are called circuit. Circuit means iron spoke connected the wire with a battery, and the key also used here to off and on, and voltmeter is also attached to the circuit, and A means ammeter. Ammeter also attached to this wire. So V means voltmeter. So this voltmeter measured the potential difference created in the circuit, and the ammeter used here to measure the current passed throughout this wire. So first one cell used in the battery and observe the V by I. V by I means first when one cell is used in battery, then the current passed through this wire is 8, and the potential current is 4, and voltmeter shows the potential difference. So potential difference shows 8 and the current shows 4. So V by I means 8 by 4 is equal to 2. Next, when two cells are used in battery, then the potential difference shows 6 and the current shows 3. So 6 by 3 is equal to 2. When 3 cells are used in battery, then the potential difference is 10 and the current is 5. So 10 by 5 is equal to 2. So one cell used getting 2 and 2 cells used getting V by I is equal to, and 3 cells are used for getting V by I is equal to. So in every time we shows the value of V by I is equal to 2. So it is called constant value of V I. So here find V by I for each set of values. We notice that V by I is constant. So V by I is here, the values is constant. Potential difference between the ends of iron spoke is proportional to the current passing through it, called at constant temperature Ohm's law. So the potential difference created through this conductor proportional to electricity current. So at a constant temperature, not a high temperature, not a low temperature. So at a constant temperature, potential difference always proportional to current. So it is called Ohm's law. So here V means potential difference proportional to current. Vi means current. So it is written as a V by I is equal to R. R means resistance. So potential difference measured in volts and current is measured in ampere and resistance measured in ohm. The sign of the ohm is like this. And R is equal to V by I and V is equal to I by R. This is a principle of Ohm's law. So from this activity we learn that the potential difference created inside the conductor. So this potential difference always proportional to current. Okay. And this is written as a V by I is equal to resistance. Okay. So it is called Ohm's law. So the limitations of Ohm laws are, so this Ohm's law valid only at constant temperature, not a high temperature, not a low temperature. And Ohm's law is not applicable to gaseous conductors and semiconductors such as a germanium and silicon. So normally germanium and silicon called semiconductors, they allowed some current through this germanium and silicon and gaseous conductors also. So some gases are allowed to pass the current, so they are called gaseous conductors. But here Ohm's law not applicable to gaseous conductors and semiconductors such as a germanium and silicon. And here we observe the two types of materials, ohmic materials and non-ohmic materials. Ohmic materials means those who obey Ohm's law are called ohmic materials. So ohmic materials means the metals when obey Ohm's law are called ohmic materials. Example, metals. Here iron spoke is a metal. So when this metal is used between the two wires, then the potential created in these two ends of the iron spokes and current passes throughout the conductors. So the Ohm's law is obeyed by the metals here. So when we draw the graph between the current and potential difference, so then we getting the straight line in this graph. So the graph between potential difference and current for a conductor is a straight line. So when we take any metals in the Ohm's law, then we are getting the straight line between the amperes and volts. Next one, non-ohmic materials. Non-ohmic materials means those which do not obey Ohm's law are called non-ohmic materials. So here instead of iron spokes, here we used the lead. Then what happens? Not created the potential difference between this lead, and also current is also not passed throughout the wires. So these materials are called non-ohmic materials. Then also when we draw the graph between the current and potential difference, the graph between potential difference and graph for non-conductor is a curved line. So here we getting the curved line. And V by I is a non-constant. So here when we take the metals, here we observe the V by I is a constant 2, 2, 2. When we used the lead between the two wires, then V by A is a constant. It means first 1, second 2, third 1, 3, like that. So it is called non-constant. V by I is non-constant. Okay. So these materials are called non-ohmic materials. Next one, resistance. The obstruction to the motion of the electrons in a conductor is called resistance. It is denoted by this letter. So 1 ohm is equal to 1 volt by 1 ampere. It means when the electrons moves through these conductors, so inside the conductor lattice ions is there. So the electrons collide with the lattice ions, though the motion of the electrons are decreasing. So this process is called resistance. And there is resistance measured in a ohms. Next one, electric shock. So it is example of applications. Ohm's law applications, the electric shock is a example given here. The electric shock is a combined effect of potential difference, electric current, and resistance of the human body. So in the Ohm's law already we learnt about the words involved in the Ohm's law. They are potential difference, current, and resistance. So when the people getting the electric shock, so potential difference, current, and resistance are involved in the electric shock. When we touch a current wire, 0.00024 amperes current flows throughout the body. It does not affect the functioning of various organs inside the body. So when we touch the current, then what happens? 0.00024 ampere current passes. Then the functioning of various organs inside the body are not affected. So resistance power is worked on this current. But when 0.0024 amperes current flows through our body, then the functioning of organs inside the body get disturbed. So it is called electric shock. So it is a most current is passed throughout the body. Then what happens? The resistance power is not working on this current, and this current is disturbed our organs in our body. So it is called electric shock. If this current reaches 0.07 ampere, it affects the functioning of the heart and being killed. So more and more current is passed inside the human body. So it affect the heart and also being killed also. So here is a table given. So current in ampere given here and effect on human body 0.001, then only we can felt. When current in amperes 0.005, pain, so we get the pain 0.0110, then the current causes involuntary muscles contractions. So the muscles present inside our body getting a contractions, and we getting the current 0.015, then the current causes the loss of muscle control. So the muscles are getting disturbed in our body. 0.070 current passes throughout the body, then when the current passes throughout the body, it affects the heart and causes serious disruption. So here very dangerous to us and also being killed also. So all these are about the electric shock. So it is example for the application of the Ohm's law. Okay.